Okay, folks, here we go. This is trying to demonstrate regression type of a situation. It's the num, twiddle num business. So here we are. I'm going to load in some data. The data is from a package called Volstad that has some bears in it. So let me run this block of code right here. And now we have some data representing bears. Here's the bears data, and we've got several different things. I want to see if we can't look at two things: weight and length. How can I predict the weight of a bear given its length? Well, let's go and upload our helper file, which is our num twiddle num helper file. So here we go. I'm going to upload to file. Let's see, where is it? It's right there, the numerical twiddle numerical helper file. Open that, bring it to the front. So let's look in the numerical twiddle numerical helper file so we can do the same sorts of things that we did in the cat twiddle cat file or the num twiddle cat file. So here we go, let's look in here, and what do we basically do? Well, we need to start with something, and so in the first place, there's some important packages I want to have, which is tidyverse and tigerstats. Let's see what I have here. I've got tigerstats and tidyverse, and in the Volstad package, I've got bears. So looking over here, I've got bears right there, and I want to go ahead and demonstrate trying to make a model that's going to explain, let's say, the weight of a bear by how long it is. So let's go to our helper file here. And in our helper file, what we were trying to explain in here, and I'm going to use the plot mechanism from ggplot. So let me grab this part here. And get the ggplot stuff. So I'm going to grab those two, copy them, put them in our file that we're working on, paste them in, and let me arrange it so that what we're going to do is grab it from the data set bears. So in ggplot, the first command is to tell it what the data set is. So that is bears. And then what I want to look at, I want to have on the y-axis the bear's weight. Well, I guess all I got to do is change the W here. And on the x-axis, how long it is. So that would be length. There we got length. And now, let's see what happens when we run this. And here's where the plot comes out. And so we see it sort of looks like an uphill slope. The longer the bear is, the more it seems to weigh. Well, sort of what you'd expect. Okay, let's go to the next part of here. And next I'm going to look at a correlation here. And I want to point out that as we grab this piece of code, copy it, and paste it over here, and get this out of the way to paste it. We want to change what? We want to change height to weight. So that's an easy change. And instead of dash height, we want to put in length. And I'm putting that in. And lastly, the data is in bears with a capital B. So we'll put that in. And let me run this, find out how well correlated they are. Well, LENGHT. How about ETH? Well, I flunked spelling in the second grade. That's my excuse. Let's try that again. So we came out with a number of pretty highly correlated, 87. But I want to put a little quote mark on here because as I was preparing for this particular example, I kept having some trouble here. So I just want to make sure that everybody knows TigerStats is needed for this to work. There are several different correlation functions in R, and one is linked from TigerStats. So to do it this way, you better have TigerStats installed, and we got it right there. We normally, in everything we do, always require TigerStats and TigerStats and Tidyverse. Bostat is where the bears data came from, so that's why we have that in there. All right, now what do we do? Let's go back to our example and build our model. So here's where we're building our model. So let me copy that and go back in here and build our model down here. So we paste that in, and let's see, we want weight. So change height into weight. And we want, well, I guess I could just grab this part here and copy that and paste it right here. That should work if I hold my mouse just right. That looks like it might work. Let's see. And so there we go. We have an answer, and It even gives us our formula to estimate how long a bear is. You just make a linear function which is 10.1867 times how long it is, and then subtract 420 plus change from it to get how much the bear would weigh. So there's an example on how you use the twiddle num data in order to make a model. Okay, you guys, let's sign off now. Go ahead and send this and get it captioned, and we're good to go. So let me stop this thing as we are speaking here.